All years, very much. I think computer kind of like, honestly, I answer that I'm not like, I can say that. So it's like basically you're.
All right, it's 5:30. Let's go and get started. All right, good evening, everyone. How's everyone doing today? Good, good. All right, so today is an exciting day. So it's our first ANSYS day. So this will be interesting, I think, because usually when last time I taught this class, I had the ANSYS activity at the very beginning. But now we're doing it after we've done all the direct stiffness stuff, the trusses, the beams, distributed loading. So I think you'll have a lot more context in terms of kind of what we're going to go over today. Okay. But of course, this is our first activity in ANSYS, and so I'm kind of operating on the assumption that a lot of you have never used it before. So we'll start kind of from the basics of just opening the software, kind of where all the buttons are, how to create a geometry, and so on and so forth. Okay. So a lot of today will definitely just will be more kind of operational knowledge in terms of how to use the software. But I'm hoping that I'll talk about it a bit too. Kind of certain parts of what we're going to learn today can be connected back to everything we'll be going over in this class. So I think it'll be kind of an interesting experience in terms of that. Okay. All right, and so here is the setting. And so what we're going to be simulating today is what I call a plate with a hole. And so we have this kind of rectangular plate. It's going to be fixed on one side, and so we're going to have a fixed support on the left, and then on the right side we're going to be applying a tensile force P, and we're going to see how the deformation and how the stress inside the material is going to change as a result of this load. Okay. All right, and so here's all the parameters. We'll be going over this today, but that's the objective for today. So there's gonna be no notes today, it's just ANSYS, and we're gonna be spending all day in this topic. Okay. All right. Any questions on anything before we get started for today? Okay. All right. So let's go ahead and get started. So let's start with just opening the software. And so if you've installed it on your laptops or on your personal computers, you probably are working with the latest version. I don't know if they're on 2024 yet, but I think last time I downloaded it was 2023 R2. But the ones in the classroom here are a couple years behind. So we're working with ANSYS 2021. Don't worry about the version too much. There's not, honestly, for what we're going to use it for, there's really no difference in between the different versions. Probably the only thing that's going to be relevant is the file formatting requirements. And so you can upgrade, and so you can take the stuff that you worked on in the class and you can bring it home. And if you try to open up your files in the latest version of ANSYS, it's going to upscale them to the latest version, but there's no downscaling. So you can't take something that you've worked on in ANSYS 2023 and work on it again in 2021. That's basically how they get you to buy their software. So you can't just buy one. You can't just get one pirated version of ANSYS and just use that for all eternity. So you have to kind of be up to date with that. But okay. So if it's your first time opening ANSYS and you open up your start menu, and you click on your folder here for ANSYS, you'll see that there's a ton of options here. So there are a ton of different programs. So ANSYS, despite its name, is actually a collection of a lot of different softwares that are kind of all cobbled together to work, all together. And so, of course, for this class, we're only going to be using a small portion of it, but ANSYS has a lot of kind of specialized features and specialized softwares for a lot of different applications. But we're just going to be using kind of the basic fundamentals. And so, the first program that you should open here is called the Workbench. And so Workbench is kind of the starting program. It's kind of I call it the hub program that kind of launches all the other necessary programs within ANSYS. And that's kind of where the main menu is. And so if you haven't already, go ahead and open up Workbench. And so depending on what computer you're on, it's going to be Workbench 2021, Workbench 2023, Workbench 2024. But you want to look for the Workbench program and open that one. Okay. All right, and then it has to load a lot of stuff, and so it's going to take a little bit of time to load, but I can go ahead and stall for time a little bit while that's going. So that wasn't so bad. That's pretty fast. Okay. All right. So was everyone? I'm guessing everyone's kind of just opening up ANSYS right now. So everyone able to at least find Workbench and kind of start opening it up. Do you have both 2020 and 2021 installed on that computer? And do either of them have Workbench? should be the 2021. Looks like 2020 is just a relic of it. So it's at the very bottom. It's called Workbench 2021 R1. Yeah, it's a lot of different programs in ANSYS. Okay. Okay, so while you guys are kind of launching it, let me get and give you a tour. So this is kind of the workbench window here. So we're actually not going to spend that much time in this window. You know, this window right here is mostly just for kind of managing your projects, but also for kind of assigning material properties. So we're not going to spend too much time here, but it is kind of useful to kind of familiarize yourself with what's here. Okay. And so the first thing that I want to point out here is everything on the left-hand side. So on this left-hand side, you can see we have a window called the toolbox. And so these are all the different type of analysis systems that are available within ANSYS. Okay. So ANSYS is actually a very versatile software. So actually the developers have done a really nice job of trying, their goal in making ANSYS was try to make it kind of your one-stop shop for all of your engineering needs. And so they have things like you can simulate fluid flow, you can simulate dynamics. They even have electromagnetism here a little bit. Okay. They have even some very specialized applications like harmonics, acoustics. LS-DYNA is a very popular software that ANSYS acquired. Modal vibration analysis, okay, thermal analysis, transient analysis, and so there's a lot of different systems here. And so the first thing that you do whenever you open an ANSYS is to choose kind of what type of analysis system or what type of analysis that you want to run. Okay. Question. So your Workbench toolbox doesn't have any of the analysis systems. It could be that your license might have expired, and so if you've installed Workbench previously under the academic license, the academic license is only good, I think, for a year or like 6 months, and so it could be that it expired, and then you know. It still lets you open ANSYS, but it's only a tease, unfortunately. And so if you're not seeing anything in the toolbox here, you may have to uninstall ANSYS and download the latest student version. If you just downloaded ANSYS recently, then did you just download it recently, Trevor, or is it or is this an older version you had on your computer? Okay. Yeah, you may want to try reinstalling it and see. Okay, yeah, that's what I figured. Yeah, so for those of you who have used ANSYS before, you may have to uninstall and reinstall it. Yeah. Okay. Well, yeah, one of the annoying things. Yeah, that's happened before when we were over COVID, and I had to kind of reinstall ANSYS in front of everyone, which was quite embarrassing. Okay, so the first thing you want to do here when you open up ANSYS is choose your analysis system. And so, again, we're not going to do a lot with the majority of this just because for this class, I mean, for this class in particular, we're focusing mostly on the theory. But in particular, we're focusing a lot on the structural simulation. So, for the most part, for both of the ANSYS activities that I have planned, we're going to work on just static structural. And we'll dabble a little bit into thermal simulation, probably for the final project. But for now, we're mostly going to do static structural simulation. So let's go ahead and so to activate an analysis system, you're going to click on the analysis system that you want. And so for us, we want to do static structural. And you can either double click it. If you double click it, it's going to create a new project for you out here. Or what I like to do is I like to click and hold and drag and then drop it into the project schematic here. Okay. Okay, and so after you've clicked and dragged static structural, you should create a new kind of a static or a project window that you see here. Okay, and then we're going to work on this for today. Okay, and so what's nice about this interface here is that it kind of shows you all the different steps that you need to complete a finite element simulation within ANSYS. And so first we have the engineering data. So the engineering data refers to the material properties and types of materials that you're going to use in your simulation. Next, we have the geometry, and so we're going to go over that in just a second. Then all the modeling, and so that includes the meshing, the setup, that's going to be the boundary conditions, and then your solution, and then the results. And so this kind of gives you a little bit of a flow chart in terms of everything that we're going to do as part of the finite element simulation. Okay. All right, so was everyone able to click and drag static structural, and you kind of have what I have on the screen right now? Okay, so let's start with the geometry. And so typically, for most finite element workflows, you're going to create your geometry in a separate CAD software. And so for the most part, this is going to be SolidWorks. And so for the most part, you're going to create your geometry in SolidWorks, and then you're going to do the analysis within ANSYS. With that said, ANSYS does have kind of basic kind of CAD software capabilities, and so if you want to do an analysis completely within ANSYS, you can do that. You can use one of the CAD softwares within ANSYS to do that, and there are some advantages that you can utilize with that too, because there are some kind of advanced features in ANSYS that only kind of work with ANSYS created geometry. So things like optimization, things like that. Okay, but for this project, we're going to create our own geometry. So before we do that, if you left click on geometry here, don't open up anything new yet. And then if you look on the right hand side of the screen, you can see that we have some properties of this project, and in particular the geometry here. Okay. If you don't have this properties window, you may have to right click on geometry and then click on properties from that right click menu. And so that's going to bring up this new menu on the right here. Okay. Oops. Okay. So we're going to change one setting here. It's a setting that you normally don't change just because you run your analysis in 3D, but for now, for this project, we have a 2D analysis. And so under line 19, you can see that there is a setting for analysis type, okay? And the default for this is 3D, just because for the most part, we do analysis in 3D. But just for this activity here, I want you guys to change this analysis type to 2D, okay? And what that's going to allow us to do is that's going to allow us to do a 2D, a 2D analysis. So it's going to save us on some cost, and it's going to, be a little bit easier to kind of visualize. And so, this is really important. So, before moving forward, make sure you change the analysis type here to 2D, just because it's going to mess up a little bit the visualization later if you don't have that on 2D there. Okay. Okay. All right, so the next thing here is we're going to create the geometry. And so let's go ahead and right click on geometry here. Okay. And after you right click on geometry, you're going to click on this button here for creating a new design model or geometry. Right. So ANSYS actually comes with several different types of CAD software. And so for the version I'm using here, we have not only design modeler, but a program called SpaceClaim. And I think if you download the latest version of ANSYS, there's even a newer version. There's even a newer CAD software, which I forget the name. But for this tutorial, we're going to use kind of just the most basic one, and so we're going to use Design Modeler. So go ahead and click on New Design Modeler Geometry. Okay. And what that's going to do is that it's going to open up a new program here called Design Modeler, where we're going to be able to build our geometry. Okay. Oh, it's pretty fascinating. Oh, never mind. It's lagging. Okay. So after you open up Design Modeler, you should have a window that looks like this. And so this is what we're going to be spending kind of the next 20 minutes on, constructing our geometry. Okay. Okay. So was everyone able to open up Design Modeler? You guys have your window that kind of looks like mine right here. Okay. All right. So let's go ahead and make our sketch. Okay. All right, so basically what we're going to do in this stage here is we're going to sketch out our geometry and then make it something that we can actually run a simulation on. Okay. And so the first thing we're going to do here is we're going to sketch. Okay. And we're going to make our sketch in this XY plane. So you can see here that from this menu here we have all three Cartesian planes. So we have our XY plane, our ZX plane, and our YZ plane. And so we want to make our plane in the XY. Okay. So make sure you have that highlighted. And if you want to view the plane straight on, I think the easiest way to do that is to go into the lower right-hand side of the screen. Okay. So you can see here you have your coordinate axes. And if you click on the Z-axis, what that's going to do is that it's going to align the view such that you're looking kind of down the barrel of the Z-axis. Okay. So this will make it a lot easier to kind of make our sketch here. Right. Okay. And so to make a new sketch, what you're going to have to do is you're going to have to, with the XY plane highlighted here, you're going to switch the tab. And so you're going to go from the modeling tab to the sketching tab. And so the sketching tab is this, well, it's hidden by this thing right now. Okay. The sketching tab is this one right here. Okay. So again, make sure that you have the XY plane highlighted and then click on sketching. Okay. And so that's going to bring up this new menu here for the sketching. And you may, if your window's being weird like mine, you may have to adjust the adjust this so that you can kind of view everything that you need to. Okay, so now we're ready to sketch. Oh, actually, one thing before we start sketching here. So let's change our units here just to make it a little bit more convenient for us. Okay, so from the top menu here, if you go click on, there is a button for the units. Let's go ahead and switch the units here. And so the default here is in meters. But because our plate here, the measurements are given in centimeters, I think, or millimeters. Let's go ahead and change our units here to millimeters. Okay. So you want to make sure that you change that. Otherwise, it's going to be a little bit annoying to kind of dimension this. Okay. Okay. And so now let's go ahead and start sketching. And so to sketch, let me go ahead and bring up the geometry again one more time. Okay. Our next step here is we're going to draw out this rectangle here. Right, so let's go ahead and draw that out. Yes, yeah. So if you're on the 2024 version, yeah, I forgot the name. So if you're on the 2024 version, the latest CAD software 2024 is called Discovery. We're not going to use that one just because I've never used it before, and so we're gonna focus on just design model. Yeah. Mm-hmm. At the end of the day, for most analysis, you're not going to spend too much time in the CAD softwares. You're going to be spending most of your time doing the analysis. And so that part, I think, hasn't changed in between the different versions. Okay, so we're going to draw our plate with the hole. And so our plate is going to start with a rectangle. And so from the left-hand side menu here, you're going to click on rectangle here, right? And so that's going to allow you to sketch a rectangle. And so to sketch a rectangle, you're going to click somewhere in the plane here. And you're going to click, and after you click once, it's going to let you to drag this rectangle here. Okay? And then when you click again, it's going to draw the rectangle. Okay? And then lo and behold, we have our rectangle here. So that's going to form the basis for our plate here. Okay? All right. Was everyone able to find the sketching tools and draw a rectangle in the screen? Cool. Okay, so next step, just like any good CAD drawing here, we're going to dimension this. And so we're going to make sure that this rectangle is the appropriate size. Okay. If you go back to our specifications here, you can see here that we have a length of 300 millimeters and a width of 200 millimeters. Okay. And so that's length and height, I guess you can imagine that. Okay. And so to dimension or to force a length on this rectangle, you're going to click on the dimensions tab. And so that's going to be from the left-hand side menu here. Okay. So go ahead and click on dimensions. By default, it's going to have the general dimension highlighted. That's fine for what we want to do. Okay. All right. So with the dimension tool highlighted, the general one, you're going to click on one side of the rectangle. Okay. You're going to drag it out a little bit, and that's going to create a new dimension there. Okay. And then you're going to do the same thing for the height. All right, so you're going to click on one side of the rectangle with the dimension tool, drag it out, click again, and that's going to confirm that you want that dimension. Okay. All right, so for those of you who are familiar with SolidWorks, this is going to be a little bit strange because normally when you set a dimension, normally you're able to specify its value straight from the window here. But the way Design Modeler does it is a little bit different. And so you can see here that it's after you click it out, ANSYS has created these variable names for these dimensions. So we have H1 and V2, okay? If you go to the lower left-hand side of the screen, you can see that we have the same variable names here. So H1 right now is 135.25 millimeters, and V2 is 75.254 millimeters, okay? So we want to change these, and so we want to update these to be kind of the right shape, okay? And so for H1 here, the width, I'm going to set this equal to 300. Hit enter, and then for the height here, I'm going to change that to 200 here. Okay, to make sure that our rectangle has the appropriate height and width. Okay. Okay. And then if your rectangle goes off screen, you can always zoom out. Okay, so you can scroll on the mouse wheel to zoom out. And if you want to pan, very useful tool here is you can hold control. So hold control on the keyboard with your left hand, and then hold the middle click on your mouse. Okay, and so that's going to let you pan your drawing kind of left and right. Okay, because if you just left click, if you just hold the middle click and move the mouse, you're going to rotate. But rotation is usually not that helpful. So usually you want to pan. So hold control, hold the middle click, and then move the mouse left and right. That's how you pan like that. Okay. All right. Any questions on this so far? Okay. So now that we've dimensioned our rectangle here, next thing I want to do here is I actually want to center it on the origin. As you can see from the figure here, we're going to draw a hole right in the middle of the plate. Okay. And so once again, we're going to use the dimensions tab here. But instead of the general dimension, we're going to use the horizontal and vertical dimensions tools. Okay. Because what these tools are going to do is that they're going to allow us to set a horizontal distance between two lines and a vertical distance in between two lines. All right, so let's start with the horizontal tool here. Okay. So with the horizontal dimensioning tool, we're going to dimension the horizontal distance between the left-hand side of the plate and the y-axis here. So I'm going to click on both here. So when I'm left click on the left side of the plate, then I'm going to click on the y-axis as well. And so you can see that creates a new dimension variable here. Okay. So my ANSYS is called it H4. And so I'm going to give this a value here. And so to make this center, this horizontal distance should be half of the length. And so that's 150. Okay. And then I'm going to do the same thing with the vertical dimensioning tool. So I'm going to click on the bottom edge of the plate, as well as the x-axis, drag it out. Okay. And then I'm going to set the vertical distance here to be 100 millimeters. Okay. So now our plate here has appropriate dimensions. It is properly 200 by 300 millimeters, and we've centered it on the origin. Okay. One small thing that you should notice is that after we do that, all of these lines here are perfectly fixed in space, so they're fully dimensioned. And so you can see that they kind of turn a brighter blue color compared to its kind of grayish blue that it was before. Okay. Okay. Any questions on this so far? Okay. Everyone able to make their rectangle? All right, cool. All right, so the last thing we're going to create here is the hole in the middle of the plate. Okay. All right, so to create a hole, we're going to go back to the Draw tab. And so from that same left-hand side menu, we're going to click on Draw. Okay. And then there's a circle here somewhere. Okay, so you may have to kind of move the menus around, but you should be able to draw a circle. So let's go ahead and click on Circle. Okay. Let's center the circle on the origin because we want this hole to be at the center of the plate. Okay. So after you click on the origin once, it's going to let you to kind of move the mouse here to specify the size of the hole. Okay. So go ahead and click another time to specify the size. And then once again, we're going to dimension this hole. So we're going to click on the dimension tool, click on General. Okay. You're going to dimension the hole, and the hole has a diameter. The hole has a diameter of 50 millimeters. Okay, so after you dimension it, come down to the bottom left-hand side screen and click this dimension and make it 50 millimeters. Okay. Your plate may look a little bit different than what's in the PDF, just because I made those images, using different settings. But this is kind of what your plate should look like. So you should have a 200 by 300 plate, and then kind of a relatively small hole in the middle of the plate, just like that. Okay. All right. Any questions on that? All right, and so now that we have the sketch, now we need to make a surface from this, and so we basically need to make a solid geometry for our ANSYS to actually mesh and run the simulation on. Right? Okay, so to do that, you're going to go to the concept window up here. Well, first of all, you're going to go back to modeling here. Okay, and so after you click back on the modeling tab from the sketching tab, you should see that under the XY plane, we have one sketch here. Okay, so that's a sketch that we just completed. And what we want to do here is we want to create a surface from this sketch. Okay. All right, and so with the sketch highlighted here, so remember, I went back to modeling here under the XY plane. I clicked on sketch 1 under the concept here. So concepts is a button on the top row of the program, and then you're going to click on this button for surfaces from sketches. Okay. Okay, so let's go ahead and click that. Okay. So after you click on surfaces from sketches, you're going to input the settings for that in the bottom left-hand side of the screen here under the details view. Okay. Okay, so from the surfaces from sketches, it's going to ask you for something called a base object. And so for the base object, you're going to click on sketch 1 here. And then you're going to click apply. And so that should specify the base object to be one sketch from your drawing here. Okay. And then after you do that, what we want to do is we want to add materials. We want to add basically add a thickness to this to the sketch. Okay. And the last thing we're going to do before we generate this is we're going to specify a thickness for this plate. Okay. Even though this plate is going to be 2 dimensions, we still need to specify a thickness. It's going to be kind of like a theoretical thickness. It's not one that we're going to visually see. But we do need it for just kind of computational purposes. Okay. Okay, so the thickness for this plate right here, we're going to specify it to be 5 millimeters. Okay. Right. So once you've kind of specified the sketch, once you specify the thickness, we can go ahead and hit generate. Okay. And then after you hit generate, you should see that your surface should generate from here. Okay. So ANSYS is smart enough to see that the hole there is an interior edge. And so it's basically going to cut out material around that edge. And then it's going to create our geometry that looks like this. Okay. And so if you did everything correctly up to this point, you should have your plate. And so all the solid parts of the plate are going to be in gray here. And then you should have a circular hole kind of cut out in the middle of the plate, just like that. Okay. Okay. Any questions on this? Okay. Everyone able to create this geometry here? Okay. Yeah. Sure. And so after you create, you're going to do surfaces from sketches here. And then after you do that, you're going to specify the settings in the bottom left here. And so you're going to make sure that you select the sketch. And so there should be, if you haven't selected yet, there should be kind of a button called apply. And so you're going to click on sketch right here. You're going to click on apply for that base object. And then you're going to specify a thickness. And so the thickness is going to be kind of the depth of the plate. And so that's going to be 5 millimeters. And then once you've done all that, there should be a button with a lightning bolt called generate. And so it should be in the top left of the screen. Yeah. And so after you click that generate, then you should have a surface that looks like this. Were you able to find it okay? All right, let me check the chat here. Question. So will there be issues if you don't center your piece on the origin? It just makes it a little bit more convenient. Honestly, for this is kind of just an introduction to ANSYS. And so, if your hole is not centered on the plate, it's not the end of the world. It's just that it's going to just be a little bit harder to kind of check your solution, kind of against what I'm doing here. So it's not the end of the world. This is not a real piece that we're going to put into action here, but if you wanted to kind of follow along, then that's where it is. Yeah. Mm-hmm. All right, everyone able to generate the geometry here? Okay. Okay. All right, and so with that, we're done. We're done in this program here. So this program called Design Modeler here is really only used to create geometries. But to actually run our finite element simulation, we need to exit from this program. So you can go ahead and close Design Modeler here. You want to be careful because you don't want to close Workbench. You just want to close Design Modeler. Okay? And so if you're like me and you have a bazillion zoom things in the way, you may want to just kind of drag the window down here, close Design Modeler. Okay. All right, and so after you close Design Modeler, you're going to come back to Workbench. If you notice, Workbench here was updated a little bit. So now that our geometry is satisfied, we have a green check mark here. And so the next step in the process is going to be model. Okay. All right, so let's go ahead and double click on model here. And so after you double click on model, it's going to open up another program called ANSYS Mechanical. And that's the program that we're going to be spending the rest of our time in for today. Yeah, mechanical, mechanical is a little bit slow, and so it may take a minute or two to kind of load up, especially if you're working on your home computer. It's even taking a while on here. So I guess while that's loading, I'm sure probably everyone's kind of in the same boat. I'll kind of share a funny story. So not this past weekend, the weekend before, I hosted a Super Bowl party at my place. And when you host a party, you buy too much food. That's kind of what you do. Having too much food is better than having not enough food for all your guests. So unfortunately, I bought way too many hot dogs, and so there are not that many people wanting to eat hot dogs. And so for the past 10 days, all I've been eating at home is just hot dogs and ketchup and mayonnaise. And so it's been a terrible experience. And my wife kind of gave up kind of 3 days of hot dogs. And so she's eating kind of nice food, kind of cooking new food, and I'm just eating the hot dogs because I don't want to throw it away. So yeah, my bowels have not been very happy with me for the last week or so. So but I'm almost done. I have 3 more hot dogs, and I think I'm just gonna just crank all 3 of them out tonight. And so after today, there'll be no more hot dogs. I don't know why it's kind of something kind of weird going on with the menus here. Okay, all right. So there's something a little bit weird going on with the menus, and so you may have to kind of minimize, or I don't know if just the system's getting old, but after you open up mechanical, you should see your plate with the hole, and it should be loaded right here. Okay. If you've opened up ANSYS and it has some kind of advertisement with like a YouTube video, that can show up sometimes. In order to kind of get rid of that, you just have to kind of click on something over here. So usually what I like to click on is just geometry, and that should bring up your plate with the hole. Okay. Okay. All right. So is everyone able to open up mechanical? They have this menu open right here. Okay. All right. So let's go ahead and continue here. So the next step is a step called meshing. Okay. Because what we have right here is we have our geometry. So this is kind of traditionally what you would see, if you made a part like this in SolidWorks, is that it's all kind of one material. Okay. But one thing that you've seen, over the last few weeks is that, in order to run a finite element simulation or do a finite element calculation, you need to have elements, right? Otherwise, there's no FEA to be done. Okay. And so the process of creating elements for an arbitrary geometry like this is called meshing. Okay. So we haven't talked about it that much in this class, just because we've mostly just been dealing with kind of relatively simple kind of truss and beam geometries. But meshing is a very important step, and a lot of times kind of what you spend the most time on doing when you're doing an analysis like this. Okay. Okay, so to create a mesh, I'll kind of show you how to create a basic mesh first. And so you can right click on mesh here from the project outline. If you notice here that it has a lightning bolt, so that lightning bolt basically means that the program wants you to do something. Okay. And then you can click on this button here to generate mesh. And so this is going to be kind of your first mesh that ANSYS is going to create for you. Okay. All right. So after clicking on generate mesh, it's going to make a mesh for you here. And so you can see that what it's done is that it's broken down your geometry into a bunch of simpler shapes, right? And so you can see here we have a bunch of kind of quadrilaterals here, so 4-sided polygons. Okay. We have a little bit of distortion around the hole, but that's okay. That's pretty normal here. But the most important thing here is that we've broken up our mesh here into all of these different elements. Okay. Now the mesh that we have here, honestly, this mesh is probably okay for this project. This is a very simple calculation, but oftentimes you want to make sure your mesh is actually more fine than this. Okay. So the accuracy of a finite element simulation often depends very strongly on the size of the elements. And generally, the smaller the elements, the more accurate your simulation is going to be. And so we can modify the size, okay? And so if you left click on mesh right here, and then you go to the bottom left-hand side of the screen, you should see that there is a setting for the element size, okay? And so right now, the element size is at the default value of about 1.2 inches. Okay. So let's change that. And so let's see how our mesh changes when we change the element size here. And so instead of 1.2, let's make our element size less than half that. So let's go for 0.5 inches. Okay. And so you can see that when you change the element size, you can see that ANSYS is telling you that you need to remesh. And so it's telling you here that the mesh that is currently being displayed is obsolete by this pink color here, okay? And so after you change the size of the elements, go ahead and right click on mesh again. Go ahead and click on generate mesh, okay? And it's going to create another mesh for you here, right? And so with the mesh size of 0.5 inches, you can see that it has made much smaller elements, okay? And so a mesh like this is going to create an even more accurate result because the elements are a lot smaller, okay? Usually what I like to tell people is that, think of your mesh as almost like the resolution on your TV screen, resolution on your phone. Okay? Generally speaking, the more pixels that you have on your TV screen, the more accurate or the more the more realistic your pictures are going to be, the better quality the pictures. Okay. The same thing can be said for the mesh. And so for the mesh here, the smaller your element size, the smaller your pixels are, the more elements, the more pixels that you could have in your image. Okay? And so we can take this down even more. So we can take this down to 0.25. Okay? And we can kind of regenerate our mesh. Okay? And you can and what you should notice is that as you make the mesh even smaller, it's going to take even longer for the mesh to generate. Okay. So that's usually the trade-off that you have when you're creating your mesh is that if you use smaller elements, it's going to give you a more accurate result, but it's also going to take a lot longer and increase the cost that quite a bit as well. Question?
Yeah. How do you change the meters to inches?
Yes. And so if you're in different units here, you can change the units. So you're going to click on home from the very top hand side of the screen. And it's a little bit hard to see because the zoom thing is in the way. But there is a button here for units, and so you can choose the units. Yeah. For this one, actually, let's go ahead and choose. Let's switch to an SI unit, and so let's switch to millimeters, kilograms, and volt, just because when we apply our load, it's going to be in megapascal, and so yeah. So go ahead and switch your units. You can choose any of the metric systems here. I'm using millimeters, but you can use kind of whatever you. Okay. So my voice is a little bit tired, so I'm gonna let you guys play around with the meshing a little bit here. And so you can go ahead and play around with the size a bit. Just kind of choose the size that you want. We can choose 5 millimeters. For this, so there is a limitation in terms of how small you can make your mesh, just because we're working with the academic version of ANSYS, or if you're working from home, there's a student version. So there is a limitation in terms of the number of elements. But for this project, this geometry is so simple, we don't really have to worry about that. So, go ahead and play around with that. If you want to see how many elements are in your mesh, you can click on statistics. And so with the mesh highlighted here, if you click on this plus arrow on the bottom left, you can check the number of elements in your mesh. Okay. And you can see that my number of elements in this mesh right now is about 2,300. Okay. All right, so I'll give you a couple minutes. I need to rest my voice a little bit. You can go ahead and play around with that, the setting a little bit, and then I'll come back in just a couple minutes to move on to the next step. Okay. And if you're having a question, just go ahead and raise your hand, and I'll make my rounds around the classroom too. right, how's everyone doing? Everyone able to kind of adjust the mesh size a little bit? For this project, you know, it doesn't matter too much what the mesh size is. You can try to aim in the same ballpark as me, like maybe around 2,000 elements. But you know, the accuracy is not going to hurt too much for me. Okay. So there are a few more things that you can do with the mesh. And so if you want to kind of play around with more of the settings, have it outlined here in the PDF. And so if you look at the PDF that's on Canvas right here, I've kind of outlined some additional mesh settings that you can do. I'm not going to focus on that for now, just because, you know, that's something that, you know, you guys can kind of work on your own. But I just kind of wanted to show you kind of the quickest path to getting a simulation. Okay. So now that our mesh is complete, our next step here is to apply the boundary conditions. Okay. So these are going to be our loads and constraints that we typically see in our problems. And so if we go back to our PDF here, okay, you can see here that we have two boundary conditions that we need to apply primarily. So we have a fixed support that's on the left-hand side, and then we have our tensile force that's going to be applied on the right. Okay. Okay, so let's go over how to apply the boundary conditions on a simulation like this. Okay, so to apply, let's start with the fixed support, so that the fixed support is kind of the easiest to do. So to apply boundary conditions, you're going to right-click on static structural A5. Okay. You're going to go to Insert. And then after you go to Insert, you can see here a list of all the types of boundary conditions that you can apply on your geometry here. Okay, so there's a lot there, and there's a lot that you can do here. Okay. For now, we're just going to focus on kind of the basics. And so the first one we're going to apply here is a fixed support. Okay. And so if you highlight over that, you'll see a little bit of a description of what that boundary condition is going to do. Okay. And so you can see from the fixed support is that it's a boundary condition to prevent a selected geometry or mesh entry from moving or deforming. Okay, so that's exactly what we want. So let's go ahead and click on fixed support here. So that's going to create a new boundary condition object underneath static structural. And what we need to do now is we need to apply it to a certain area of the geometry. Okay. Okay, so if we go back to our figure here, you can see that the fixed support is going to be applied on the entire left-hand edge of the geometry here. Okay. So let's go ahead and click on that. And so, you know, make sure, be careful a little bit so you don't click on too much of the geometry here, but you want to make sure that just the left-hand edge is highlighted. Okay. And so if you click it once, you should see that it should be highlighted in green like this. Okay. All right, so go ahead and click apply. Right. From the bottom left-hand corner of the screen. And you should see that your fixed support is now being applied on the left-hand side. Okay. All right, the next thing we're going to apply here is our load. So we're going to apply a tensile load on the right side. And the way that we're going to apply it is actually as a pressure force. Okay. And so if you look at the units from the document here for the load P, you can see that the units given for it are in terms of megapascal. Okay. So this is I would say this is a little bit non-traditional. Usually that you would want to apply the force as a load as a force, and so it would have units of like newtons or pounds. But the fact that the force here is given to you in terms of pressure, in terms of megapascal, let's go ahead and apply the force in those units. Okay. Okay, so just like we did with the fixed support, you're going to right-click on static structural. We're going to insert, okay, and then you're going to go up to pressure up here. All right, so go ahead and click on pressure. Okay, so for a load here, you need to specify two things. And so the first thing you need to do is specify the part of the geometry that you want to apply it on. Okay. And so we're going to apply this on the right-hand side. So just like we did for the fixed support, you're going to click on the right edge. Okay. Hit apply here on the bottom left-hand side of the screen. Okay. So that's going to highlight the right edge of your plate here as a pressure boundary condition. And then the next thing that you're going to apply here is you're going to apply the magnitude of the force as well as the direction. Okay. Okay. So first thing we're going to do here is we're going to change the direction. So we want to make sure that we can apply the force in the positive X direction. And so the way that I usually like to do that is I usually like to change the force definition here. Okay. Okay, so with the pressure button highlighted here from the project outline, we're going to change some of these settings here in the bottom left. Okay. All right, so first thing we're going to do is we're going to change the definition. And so instead of applying the force normal to the surface, we're going to change that to components. Okay, so we're going to define the force directly in terms of its X, Y, Z components. Okay, so go ahead and click on components. And so after you click on components, it's going to change the specification here. And so you can see here we're able to specify both the X component and the Y component of the force. Okay. All right, so we don't have any Y component here, but we do have an X component. So let's go ahead and specify the force as 10,000 megapascal. Okay. And if it doesn't say megapascal, you may have to change the units up here. So I have I'm using this metric: millimeters, kilograms, newtons, second millivolts, milliamps. Okay. Okay. All right, so was everyone able to apply our two boundary conditions, our fixed support and our tensile pressure boundary condition? All right, and so with that, we're just about done with the settings here. Okay, so now we are ready to solve. Right, okay. And so the nice part now is that the majority of our work is done, and so now we can kind of let the computer kind of do most of the work for us. Okay, and so usually at this point, we have our mesh, we have our elements, we have our boundary conditions. And so if this were kind of a traditional kind of direct stiffness type problem or a hand calculation, we would start kind of assembling our element stiffness matrices. Okay. The problem here is that, if you imagine each of these tiny little elements here, each of them are going to have their own element stiffness matrix. And so for a mesh of 2,300 elements, that means you would have to write 2,300 element stiffness matrices, which is only something a cruel and unusual person would make you do. So, but this is something that the computer would really excel at. Okay. So you absolutely could solve this by hand. It would just be kind of way too tedious to do. And this is the kind of task that the computer would excel at. Okay. But if you think about it, at this point, we have all the information that we would traditionally have for our direct stiffness problem. So we have our geometry, we have it broken down into elements. Each of those elements you can measure the properties for. So you can measure its length, its area, you can measure its Young's modulus, things like that. Okay. So from all that information, you can construct each of their element stiffness matrices. You can see visually here how all the elements are connected. And so once you have all of those, you can construct your global stiffness system. Okay. For a geometry like this, it's going to be a very large system. And so normally kind of we're accustomed to kind of 8x8, 10x10 systems. The global stiffness system for this would probably be somewhere on the order of maybe 20,000 by 20,000. So 20,000 columns and 20,000 rows. So, not very practical for a human to do. But for a computer, it's pretty easy. Okay, so the last thing we're actually going to do before we solve it is we're going to specify our output fields. And so we're going to right click on solution A6. Okay. You're going to go to insert. You're going to go to deformation. And then you're going to click on total deformation. Okay. So all we're specifying here at this point is that, now that we're ready to run the simulation, we need to tell ANSYS, how we want to display the results, because there's a lot of different things that we can display here. Okay. And usually it's a little bit of a information overload to display all these things. And so usually ANSYS has you choose kind of which output field that you want to view. Okay. All right. So at the very least, let's go ahead and view our total deformation. So that's going to show us how much the plate is deforming. Okay. And then let's also include the equivalent stress. Okay. And so be careful. Don't do strain here. You want to make sure you do stress, and you want to do the equivalent von Mises stress. Okay. Okay, so now that we have our mesh, we have our boundary conditions, we've specified our output fields, we are ready to run. So let's go ahead and click solve. Okay. So the solve button is a lightning bolt that should be near the top of the screen. Okay. Right. And so it should only take, maybe just like maybe 10 seconds to run, maybe even less than that if you have a coarser mesh. But now we are ready to view the results. Okay. Okay. So if you click on the different result fields here, so you can see here that we have the field for total deformation, and we have the view for equivalent stress as well. Okay. And so the way ANSYS kind of displays its results to you is that it displays it as a color contour plot. Okay. And so you can see that it's highlighting different areas of the geometry, different colors, and each of those colors correspond to a different amount of deformation here. Okay. And it's a fairly smooth scale. And so I know all you see here are just, 7 colors. But there's, each color here kind of represents a range. And so you can see here, everything in kind of the deep red is between 16.85 and 14.98 millimeters. Okay. But the colors here indicate kind of where all the deformations are occurring in this case. Okay. Okay, and then you can do the same thing for the stress. And so usually the stress field is something that's kind of really interesting for people who are using FEA, because a lot of times you're running FEA to determine whether your part is going to deform or your part is going to fail or not. Okay, and so the way to test whether your part is going to fail is that you're gonna run your simulation, you're going to compute the equivalent stress, and then you're going to check to see if the equivalent stress, usually the maximum equivalent stress, if that exceeds the yield strength of your material. Okay, so we'll dive a bit deeper into this in activity 2. This activity here was just kind of getting used to and learning the ANSYS interface. But in activity 2, we're actually going to do a stress analysis, and we're going to do a failure test on a bike crank. Okay. And if you want, you can play a little animation of your plate deforming. And so if you go to the bottom here under graph, you can click the play button. And so you can see your plate here being stretched in real time. And you can see how the stress actually develops as the plate deforms and reaches static equilibrium. Okay. All right. Any questions on that? Okay. All right. So that's ANSYS, and so that's kind of our first introduction of running kind of an ANSYS simulation from start to finish. There are additional activities that I would like you to do, and so if you open up the PDF that's on Canvas here, and you kind of scroll all the way to the bottom here, you can see here that there are different activities for you to do. So problem one here is just kind of interpreting your results, and so just looking at the results that we just obtained. And answering questions of, what is the maximum deformation? Where does it occur? What is the maximum stress? Where does it occur? Okay. And so you can read those results just from the color contours here and from the legend. Okay. So you're going to be turning a lot of this in as well. And so for each question here, I'm basically telling you kind of what deliverables that I would like you to do. And so for problem 1 here, you would basically just have to take a screenshot of the total deformation plot and the equivalent stress plot, and then include that in your submission, as well as the answers to these questions here. Okay. Problem 2 here. I want you to change some of the settings and see how they affect the results. Okay. So I want you to do things like change the loading. I want you to change the size of the hole. So to change the size of the hole, you're going to have to go back and design modeler and change the geometry that way. Okay. Change the mesh size. Don't worry so much about D and E. So D and E are optional. You're definitely welcome to try them out if you would like. But that gets a little bit more into kind of 540, which is kind of the partner for this class. And so if you want, there's instructions for how to kind of modify these things in the text of the PDF. But I kind of skipped it in my explanation now just for the sake of brevity. Okay. Once you've iterated on those, there's some short answer questions that you can answer here. Okay. And then problems 4 and 5 here are kind of the next part of your direct stiffness problem set. And so this is kind of a follow-up to homework 1. So problem 4 here has some beam problems, and so you should be able to do those based on what we've done. And then problem 5 here is some frame problems, and so we'll go over how to do these over the next couple of lectures. Okay, so we have about 20 minutes left in class, and so you're welcome to kind of stay here and kind of work on the rest of the activity. And if you're running into any issues, you can go ahead and ask some questions. But are there just any questions I can just kind of answer in general from the class before I let you guys loose? Yeah.
Is there like how we did this whole simulation? If I were to want to do this at home, what kind of file type?
Yeah. Oh yeah. Good question. So if you want to take this home and work on it, you have to save it from Workbench here. And so if you're transporting it between different computers, the way that I actually recommend it is that you use this archive function here. And so because if you save this, so I'll go ahead and show you this. And so let me go ahead and say today's date, Feb 20, 2024, ANSYS 1. So we go ahead and save this under documents here. Okay. And so if you just save the project outright, and you go to documents here, you can see that it actually saves a couple things. And so it's a little bit misleading because ANSYS saves this file right here. So people think that this file right here is the one you transport between computers. But this file here is just a link. And so actually all the project files are inside this folder for ANSYS 1 project files. And so, and it gets a bit complicated. And so, you would think that you would be able to just transport both of these files to your home computer. But it actually causes some errors because what ANSYS expects is that when you launch this file right here, it basically links to the locations of these files kind of directly. And so if you move this between computers, even if you move the location of these files to a different folder, it's going to cause some errors when you try to launch it again. And so the way I generally recommend it is that you're going to go to File here from Workbench. You're going to go to Archive. Okay. And then it's going to save a new file type called the WBPZ file. Okay, so let me go ahead and save it. It's gonna ask you what you want to archive, so you can just go ahead and archive everything. Okay. All right, it takes a little bit of time because it has to. It's what it's basically doing is that it's zipping all your results into one. Okay. Oh, it's on the desktop. Whoops. Okay. Okay, so on the make sure you save it in the right folder. But it should save a new file here called February 20th. Oh, okay, so it saved one single file here called WBPZ. So if you want to take this file home, this is the one that you transport home. And then when you open this up on your computer, you just double click this. And if you have ANSYS installed on your computer, it'll unpack it and then open up your project that way. But I definitely recommend the archive option over trying to move the files. All right, any other questions on this? Okay, all right, so I'll stick around until 6:45, and so if you have kind of specific questions about the activity, you can ask. If you want to just stick around and work on the activity, we have the room until 6:45. Normally, I would say you can stick around after, but I know for sure that there's another class coming in here at 7. But if you just want to work on this at home, you're free to go as well. So thank you guys for coming today. Hope you guys enjoy the rest of your day. If you guys are driving home today, make sure you drive carefully. It's really wet out there and people are driving crazy. So, make sure you drive carefully, and I will see you guys on Thursday. All right, question. So are we ever going to cover Fluent when we enter the heat transfer portion of this class? We may cover heat transfer a little bit, but I'm not planning on covering Fluent. No. So that's a topic for 540. That's the other ANSYS class. That's the other finite element class that's more focused on ANSYS. Yeah. I do have some handouts. I do have one handout that covers Fluent. And so if you're interested, I could give you that handout, and then it's kind of a self-directed kind of handout. So it's kind of similar to this activity that we have here. So that's kind of a decent introduction, and of course you're free to kind of try it out on your own and ask me questions. And I'm very open. I'm open to kind of working with you directly if you're really interested in Fluent. But I'm not planning on covering in the class. Yeah. Mm-hmm.
If hypothetically you've got ANSYS 21 and SolidWorks 24, can we take the model from SolidWorks and put that into ANSYS?
Yes. Yeah. So from SolidWorks, you would actually, so ANSYS actually doesn't read SolidWorks files directly. So you would have to convert your SolidWorks file into either usually I like a parasolid file, so that's file format x_t. And so from SolidWorks, you would click save as and then save as x_t file. And then you can upload that into ANSYS. And so that file format is kind of irrespective of the different versions. So that's where. You know,
Change the like match the fit on meshing, like whether we meshing too high or too low, or we keep it in a shape like triangular. Is that change the final output? Like, or is it?
it does have an impact on the output, but for something simple like this, you're not going to see much of a difference. Yeah, yes. That's probably, you're probably gonna see more of an impact on more complicated cases for that, but there are kind of subtle differences between them, but you're probably not gonna see them on something like this.
So is like while choosing the meshing, like is there any criteria that they would take into account, like that it should be within this range or they can use?
Yeah, so for the main thing with the meshing actually is more the size. So you want to make sure that your mesh is kind of an adequate size. So there's a test that you can run, and we'll talk about this kind of near the end of class called a mesh convergence test. And so you're basically going to run the simulation at different levels of mesh density. So you're going to make the mesh kind of smaller and smaller and smaller. And then eventually, what you're going to see is that for larger mesh sizes, the results are going to change. So as you change the mesh size, it's going to change with the mesh. But after a certain point, you're going to try to keep refining the mesh, and the results aren't going to change. So you reach a plateau. So you want to kind of be in that range where that tells you that your mesh is basically as optimal.
Thank you.
Yep.
I missed class last week.
Uh-huh.
I wanted to ask you what we did. Was it the rest of the note taking?
Pretty much, yeah. So I actually, let me see, because I actually forgot to upload one of my lectures from my other classes, but let me see if I did for this class too.
Yeah, I didn't see a video.
Okay, yeah, so I need to upload this one, but yeah, just I'll go ahead and upload that when I get back today. Just check out both the lectures and kind of catch up from there.
Okay, thank
Yeah.
you.
Mhm. See you guys.
On the iteration problem.
Yep.
Do we need to do parts D and E or?
No,
can we skip those?
You can skip the.
And then problems 4 and 5, do those require using ANSYS or? do we
No.
do them by hand?
Those are.
All right, I'm good. Thank you.
Yep.
Thank you.
See you guys.
A random question.
Yep.
So like, can you actually see like the matrices that ANSYS makes or? No?
No, you can't, unfortunately. That would be cool.
Yeah.
But I think that's proprietary.
Mm.
They're using the same basics as what we're doing, but then they do. So in the world of like solving really big systems of equations, there's a lot of kind of special techniques that you have to use. And so there's like special they call it like a preconditioner for the matrix. There's like post conditioners, there's like special kind of special algorithms to use. So that's where they make their money. That's their bread and butter in terms of how they solve their system. So if they show details on the matrix, people would figure this out. So they don't want that. So there might be a way to extract it if you're really savvy, but it's definitely not something that they want users to see on the regular. It would be cool though. I would love to see. I would love to see it. Even just the structure of the matrix, but yeah, that's not something to show people.
So, because like we use like different like methods where like beams and like what is it like the trusses and stuff. So
Yeah.
does that kind of correspond with ANSYS too, or?
A little bit too. So actually, it's actually good you're taking this class after 410. So up to this point, it's basically just been a repeat of 410, probably for you, right?
Mhm.
But then once we start to get into kind of what I call kind of more traditional FEA, you'll see how the elements stiffness matrices for like a 2D element and 3D element is actually constructed. So I think we touched on it a little bit in 410 last semester with like the different shape functions.
There's like the hexahedrons.
Exactly, yeah. So we'll dive into it more deep here. There's the limit to how much we can do because of just the time of the class and what we can actually accomplish on paper. But you'll actually start to see those shape functions in practice and how to go from like a shape function to like an element stiffness matrix. And that'll kind of factor into the final project too. So you're getting the full FEA, almost the full FEA experience. You would need to take 540 as well. 540 is more ANSYS stuff.
Mhm. So, I mean, in that class, are we gonna do like the matrix stuff again, or?
In 540?
Yeah.
No, 540 is all ANSYS.
Oh, okay.
It's just ANSYS all day. So there's the only thing you do on paper is just whatever notes that you write. But yeah, it's all ANSYS all day with 540.
Okay.
That's the one that generally people might like more than this class.
Have a good day.
Thanks. You too.